We're on lesson 4 of chapter 3, which focuses on slope and then rate of change. So first we're going to find positive and negative slopes. We'll find vertical and horizontal slopes. Then we'll use a graph to find and compare rates of change. First, what is a slope? Well, a slope tells you how steep or how not steep a line is. And we use slope many different ways in our lives. We use it when we go skiing, for example, or when we roof a house. And we could find slopes of a line using this equation here, y equals mx plus b. So usually it's y equals the slope, or how steep this x line is, plus b, which is the y-intercept. So that's how this is written here. Y equals the slope times x plus the y-intercept. And here's how we find slope. The slope is rise, or change in y, over the change in x. Then we multiply that times x and then plus the y. So for example, this would be a rise of 3 and a run of 2. So therefore I would have y equals 3 over 2 and multiply that times x. And then I would be plussing the y-intercept. Where is it across that y line? Right here at -2. So that would be my slope-intercept form. Let's see if we can apply that to these ones now, finding positive and negative slopes. You can tell apart the positive and negative ones because the positive lines go up as you increase your value in x. So y goes up as x goes up. Negative ones, as you go up with x, the line goes down in y. So let's first find the slope of this positive one here. So I need to find rise over run. To do this, I need to find 2 points in the graph where it lines up perfectly with the grid. For example, I see this crosses right here perfectly at -4, +2. I also see that it crosses perfectly at -1, +4. So I'm going to mark these spots off. So now we can do our rise over run formula, right? Y equals mx plus b. So what's the slope of this? Our slope would be rise over run. So the rise was 2. The run was 1, 2, 3. So the rise was 2. The run was 3. So 2 over 3 would be my slope. So y would equal 2/3 x. And then we can always do the intercept as well. Where does it cross when the y is at 0? Where does it cross when the x is 0? That looks to be somewhere around 4.75, somewhere around there. That would be what our y-intercept would be. Here, let's do this negative one. So I'm looking for places where it crosses really perfectly at the coordinates. Well, here's a spot right here at +3 and +6. And then if I go down the slope, I see another one here at +6, -1. So here we can use this rise over run again. Y equals the rise over run times x. So the rise would be, or fall in this case, would be 1, 2, 3, 4, 5, 6, 7. It went down 7, so the rise would actually be -7. And then the run would be, starting here, this is where that is, 1, 2, 3. So -7 over 3 would be my slope. And I actually keep this, I usually keep this as an improper fraction. Some people make you change it to 2 1/3, but I actually kind of like it as an improper fraction because in that case I know how much to rise and how much to run. In this case I would fall 7 for every 3 I go over. I can't really find the y-intercept right now because the graph doesn't go that high, so I'll just find the slope, which would be -7 over 3 or -2 1/3. Here we're asked to find the slopes of these vertical and horizontal lines. So for example, if we're going to do rise over run from A to B, our rise for this one would be 0. Okay, so it'd be 0 over what? Doesn't really matter because 0 divided by anything would be 0. But for the sake of this, we'd say 0 over 9. 0 over 9 equals 0. We have a slope of 0. It's not positive, it's not negative, it's just a flat slope. Here we have a slope of C to D. This looks like to be going straight down. So we would say rise, which would be positive 6 to negative 4. That'd be a rise of negative 10. And then that would be over 0. Any number divided by 0, if you remember, is undefined, right? Divided by 0 cannot divide by 0. See that? So this actually doesn't really have much of a slope either. So this would be actually an undefined slope. So for this part, we're going to compare rates of change according to a real-world situation. A community theater performed a play each Saturday evening for 10 consecutive weeks. The graph shows the attendance for the performances in weeks 1, 4, 6, and 10. Describe the rates of change in attendance with respect to time. So if we're going to compare from weeks 1 to week 4, we could do rise over run to find the rates of change between week 1 and week 4. So let's do that. It rose from 124 to 232. So we do 232 minus 124. That'd be 108 for our rise. And then for the run, we went from 1 for x to 4 for x, so that's a change of 3. So that'd be 108 over 3. So if we're going to divide that, that would give us an answer of 36. So from week 1 to week 4, it went up 36, an average of 36 every week. So we say 36 per week. Now we have weeks 4 to 6. So we have a downward slope now. This will be a negative slope. You see it's going down as x increases. So we go from 232 down to 204. So the rise would actually be negative 28. And then the run, we went from 4 to 6, which is just a change of 2. Negative 28 divided by 2 would be negative 14 per week. So during these weeks, it went down at that rate. For the last one, we would have another fall. So this would be another negative slope, actually a steeper negative slope. See how this one's a little flat and this one's steeper? So this one should be higher than negative 14. We have 204 and 72. So that fell 132, so negative 132. And that fell over the course of 1, 2, 3, 4 weeks, from 6 to 10. So we'd put that over 4 and do 132 divided by 4, and that gives us 33. So that'd be negative 33 per week. So that's how much it fell per week during these weeks.